So today we are going to continue talking about solving systems of equations, but we are going to look at equations that have 3 variables instead of just 2. So if we were solving a system with 2 variables, in order to get a solution, we had to have 2 equations, right? So if we are going to have 3 variables, then we have to have 3 equations in order to get a solution. So we are going to look at systems where everything is just to the first power. With these, we're not going to do higher powers. So on this one, our strategies are going to be very similar to what we've done in the past. So we have substitution, we have elimination. The issue is the problems will become exponentially longer because I threw in another variable. It's not like I can necessarily just add all 3 equations together at once and get all but one variable to cancel out. That may occasionally work, but most of the time it won't. Instead, we're going to take 2 equations at a time, put them together, and eliminate one variable. So let's say I decided to take the first and second equation. Okay, if I took these 2, I could take the top one times 3, and that would eliminate my y. So I get 3x plus 3y minus 3z equals 93. 4x minus 3y plus 2z equals 60. So then I get 7x minus z equals 13.
Solve for z.
Okay, we can get the z by itself, but we're definitely not going to have just a number answer, are we?
No.
So what we're going to do now is go back. We have not yet used the third equation, so I'm going to use the third equation, one of the other 2, and I need to eliminate the same variable that I just eliminated. So the first time I eliminated y, so I need to eliminate the y from this one. Which one do you want to pair it with? The first equation or the second?
First.
The first. And if I wanted to eliminate y, now I'd have to take the first one times 2. So I have 2x plus 2y minus 2z equals -2, and my third equation. So when I put those together, we get 4x minus 5z equals 3. Okay. Now I am down to 2 equations, and they both have the same 2 variables. If you don't eliminate the same variable both times, like we took the first and second and then the first and third, if you hadn't eliminated the same variables, you would get to this point and still not be able to solve it. So it's very important that we pick the same one. However, now, because both of these have an x and z, I'm going to put them together and eliminate something. So do you want to eliminate the x or the z? Z. And we would do that by taking this one times. So that gives me a negative 35x plus 5z equals a negative 65. This one we have 4x minus 5z equals 3. So then when I add them together, we have a negative 31x equals a negative 62. Divide, and x is 2. Yeah, so we have to now work backwards, start plugging it in. We could plug it in to one of these equations. So it doesn't matter which one. So if I went with the first one, 7 times 2 minus z equals 13. So negative z equals -1, so z is positive 1. So now we have x and z, so we go back to the original. Huh? You would subtract your 14. Because it's 14 minus z. It's okay. I could very easily have made that mistake. So if I go back to the first one, x plus y minus z equals -1. So my x was 2 plus y minus z equals -1. Yep. Or if you wanted, you could add them first. The 2 and the -1. Yep. So that's 1 plus y equals -1. So y is -2. When you write your answer, we go alphabetical. So x, y, z. And you know you can check it always by plugging back into the original. 2 plus -2 minus 1 is -1. 4 times 2 is 8. -3 times -2 is 6. So 8 plus 6 is 14. Plus 2 is 16. So it should work for all 3 equations when you plug it back in. All right. Is that one okay? Good. Let's do.
I should just then randomly throw this at us yesterday, just like, okay, now 3.
What, you think it would have been too much if I did it in one day?
Probably. First and third equation.
Okay.
Take out the x, get rid of the x.
Why would you not get rid of the y? It's already negative.
Well,
You can get rid of
first and
whatever you
third,
want.
x is an x.
Alright, so first suggestion we have first and third. If we want to get rid of x, we have to take one of these times -1. Do you guys have a preference which?
Yep.
So if I took the first one times -1, you get -x plus y minus 5z equals 6, and x plus 3y plus 2z equals 5. So if we add those together, x's drop. So 4y minus 3z equals 11. All right. We have to use the second equation. And we have to eliminate x again. So which one do you want to pair it with? Okay, so if I put it with the third, we would have to take the third one times -3.
Oh,
I add those. These cancel. So we have -6y minus 7z equals -5. Sorry, and now down to 2 equations that both have two variables.
John Peggy was in the room. I've never played both now. I would say multiply the one in blue by 2 and the other one by 3.
Okay, so we do have to multiply both to get something to cancel. So if we want to cancel the y, we have to take this times 3 and this times 2. So 12y minus 9z equals 33. Negative 12y minus 14z equals negative 10. So those cancel. Negative 23z equals 23. So z is negative 1.
So if any of the if any of the two end up in a no solution or like an infinite solution, would the whole equation be? Okay.
And we'll look at some where that happens, but yes, if that occurs, then the whole thing becomes. All right. So then we now know our z, so we plug that back into one of these two, doesn't matter which, so if I went with that one, we have 4y minus 3 times negative 1 equals 11. So 4y plus 3 equals 11. So 4y is 8, which means y is 2. Now we have y and z, so we plug it back into the original. So if I did the first one, and I don't know my x, what did we get? Y was 2 plus 5 times z was so we get x minus 7 equals negative 6. So x is 1. So my answers are 1, 2, negative 1. So if we look at this, the third equation already doesn't have a z. So we can eliminate whatever we want, but it would be nicest if we took the first and second and eliminated the z, because we already have equation with that. So do we have to do anything special to eliminate the z there? No. So if I add those, we get 3x plus 2y equals 3. So now here's an equation with x and y, here's an equation with x and y. If I want to put those together, we take one of them times a negative 1. And we add them together, and we get 0 equals 3. But does 0 equal 3?
In an alternate universe.
Yeah. So when we see that, we know our answer is no solution. And what word do we usually write with that?
Inconsistent.
No solution, inconsistent. A system that can't be solved is called inconsistent.
So will it always be like that if you're missing a variable?
No, that just worked out this way. Any questions there? Okay. I'll give you guys another one. Since that one really didn't turn out to be all that long. Okay. What'd you guys do first. What variable did you eliminate to start with?
Y.
The y. So if you did the first and the third, we can just add them together.
5x plus 2z equals
Okay, and then if we add the second and third, we can cancel the y as well.
2x plus 2z equals 10.
So now I have to put those together. We could eliminate the z if we just take this one times a negative 1. So we get 5x plus 2z equals 18. And 2x minus 2z equals negative 10.
X equals 8.
So x is 8/3. And now it doesn't mean you did something wrong with a fraction. That can happen. So now we have to find our z. So we have to plug this back into one of the equations. Doesn't matter which one. So if I just went with the first one. So 5 times 8/3 plus 2z equals 18. That would be 40/3 plus 2z equals 18. Subtract over 40/3. So 18 minus 40/3 gives us
62/3?
we're sub-
We subtract.
Oh.
14/3.
Anyways,
What the heck?
Nobody's double checking.
I do math in my head a lot easier.
14/3, yes.
Okay. And then to
My
get rid of
calculator
the
didn't like me
2,
for a second.
we divide by 2 or multiply by a half, and it gives us
7/3. Wow, I did something wrong because I got 31/3.
So now we have x and z, we need y. So we can go back to whatever up here. So if I went to maybe the middle one. It's a negative x, so negative 8/3 plus y plus my z, 7/3 equals 1. If I add those together, I get negative 1/3 plus y equals 1. So that would be 4/3. My answer is 8/3, 4/3, 7/3.
So it's in denominator. So at least they're all the same denominator.
See, it wasn't so bad. Alright, I'm going to stop here today. We are going to continue this section Monday. We'll look at some that have infinite solutions, some that have some word problems with it. So there's a Math Excel assignment open, but it also includes a couple word problems, and I think number 4, you might want to skip that one for now as well. So you can definitely do the first 3, and then after that, if you want to jump around, you're welcome to.